Now, we talked about before, the goal of today's lesson is to fully factor a polynomial, because if it's written in standard form, it's not as easy to graph. So we want to take a polynomial written in standard form and factor it out all the way, because when it's in factored form, it's easier to find the x-intercepts, the end behavior, and graph it. Now for today's lesson, I'm going to tell you what one of the factors of this factored form is. Which means you know it's going to look something like that. This is my factored form of this, and I know one of the factors is x minus 2. We're solving for the big blank. Well, if I just think about solving for this big blank, I would divide both sides by x minus 2, because that would solve for it. And hey, look at that. That's a division problem. So let's take your box method, and yes, I am going to ask you to keep using the box method for now. Give it a couple more chances. And you are trying to solve this. So use your box method, fill all this in, and whatever your answer is here, that's going to be the blank that goes there. Pause the video and try that out. Let's check your work. Here's your boxes all filled out. If you missed anything on that, pause the video, look over your work, and figure out where you went wrong. But we have this is our answer, so now I wrote it out in factored form. You'll notice we got a remainder 0. If you know that you are factoring a polynomial, you should always get remainder 0, because if they're perfect factors, they're not going to have a remainder. Perfect factors, you should just be able to straight multiply them together to get your answer, no remainder needed. So there's a little check step for you. If you're factoring, you shouldn't have a remainder. Now, at this point, I am not fully factored yet, because I do need to factor this quadratic. So this is our easy factoring, because we just have a leading coefficient of 1. So I just need to multiply to -7, add to +6. That's going to be a +7 and a -1. That multiplies to -7, adds to +6. Now that it's fully factored, I can set each factor equal to 0 and solve to find my x-intercepts. So this graph, this polynomial, is going to have x-intercepts at 2, -7, and 1. Notice the exponents on all of these are a 1, so they will all be multiplicity 1 x-intercepts. And now we could graph this. So that's the whole point of today's lesson, is doing this division to get this part, and then factoring your quadratic so that you can solve to find all the x-intercepts, or we also call those the zeros of this polynomial. So now it's time for you to try one on your own. Once again, I give you a factor, so you need to start with your boxes. And you are trying to factor 2x cubed minus 5x plus 3. So factor that out. Then you're going to write your answer as the factor I gave you times whatever you get. And then you want to factor this quadratic answer you get. And remember, if it's not factorable, then you do the quadratic formula. But at the end, you should end up with 3 answers, just like we did up above, all x equals answers. So pause the video, try this one out all on your own, and then come back to check your work. Let's check your work. So check your box. This should be the answer that you get. If you didn't get that, go ahead and pause the video and see where you went wrong and figure it out. So I know that is what goes here. Now I need to factor this. This is our harder factoring because I have a 2 in front. So I do the first times the last, gives me -6. I need to multiply to -6 and add to +2. Nothing works. which means this is not factorable, so I've got to do the quadratic formula on this instead. So I did the quadratic formula, and these are the two answers that I got, both with multiplicity 1. And don't forget, I also have an answer from this. I have x minus 1 equals 0, so that gives me an x-intercept at 1 with a multiplicity of 1 as well. So let's try one more of these. Here we have a 4x to the 4th minus 4x cubed minus 11x squared plus 12x minus 3. And I know x equals 1/2 is a 0 of multiplicity 2. So if x equals 1/2 is my 0, then x minus 1/2 is my factor. Just like we did over here where x equals 1 is my 0, x minus 1 is my factor. And this thing has a multiplicity of 2 on it. So I know I'm going to have x minus 1/2 squared, and then I'm going to have some blank here. Now that multiplicity is a little new. We haven't done anything with that yet. All that means is that when you do your box method with x minus 1/2, you're going to do it twice. The first time you're going to do it with 4x to the 4th minus 4x cubed minus 11x squared plus 12x minus 3. Then you'll do it a second time using whatever answer you got from the first time. That's what the multiplicity 2 means. It means you can do division with this twice. So let's do this right now. Let's just do the first box with this answer and check if you get that right first. So pause the video, do your first box division with this one, and then come back to see how you did on that. Check your work on this. If you did not get that, pause the video to see where you went wrong so you can figure out what you need to fix before you move on. So this is the answer I got from that division box. So that is going to become my new answer, and I'm going to do a division box with the same factor because it has multiplicity 2, but with the answer I got before. So pause the video, do this division box now, and then come back to check your work. This division box got a little weird on you because right here you ended up with a negative 2x squared, which you already have. So you needed a 0x squared so that when you combine those, that you get the same thing, which means up here is a 0x, so that when I multiply those, I get that. And then I multiply that and get that, which tells you these combined should give me my negative 12x. So then you could get back on track. So it was a little strange, but you can still get 2. There's your answer. And now that I've done the division with it twice, I've taken care of both multiplicities. So this answer here is what goes there. So all I need to do is fully factor this. So I would notice first that they have a 4 in common. And I'm going to take that out just to make this factoring easier on me. I'll move that 4 out in front. Oops, drop my squared. And hopefully you notice that this is difference of squares. It might be a little weird to you at first. If I gave you x squared minus 16, you'd probably pretty quickly factor that to x minus 4, x plus 4. That's called difference of squares. Anytime you're subtracting, you take the square root of that one, and that gets your first 2 things, and the square root of that one, and that gives you your second 2 things, and it's plus and minus. And if you were to multiply that back in, you would get the same thing. So this is a 3, which is not a perfect square, but I can still do difference of squares on it, where the square root of this becomes that one, the square root of this becomes those ones, and if you were to multiply all that back together, you would get this. So that is our fully factored form. Now that I have my fully factored form, I can set each factor equal to 0 and solve for my x-intercepts or my roots. So I get x equals 1/2 with a multiplicity of 2, x equals root 3 with a multiplicity of 1, and x equals negative root 3 with a multiplicity of 1. And there's all my answers. So that is how we can use our division to fully factor a polynomial all the way and then take our fully factored form to find those roots or those x-intercepts. We have one more thing to cover in today's lesson, and that is the remainder theorem, and we'll do that next.